Hello, welcome back to BlenderSushi Live Noding. In this episode, we're gonna take a look at how we can create this kind of setup using Sverchok. It's actually it's a one video that's where we can kind of hack like a curve object using Sverchok. In this one, we actually we're gonna generate the curve on the fly from Sverchok to modify these objects. That's obviously I'm using blender modifiers, array modifiers, and then there's this curve that comes from Sverchok, and then there's this wireframe objects, and the rest is actually pretty simple. You know it already. You can create spiral like this quite easily, and this is just basic sine and cosine, and you can control the speed and whatnot. It's actually super simple. I just need to do this before I do the next one where we're gonna use Sverchok to hack to like a curve object that's already in the 3D view. This one, with this curve, we generate the curve on the fly. Okay, so let's get started. So the idea is to use Sverchok's object ID of type of curve, but the curve is slightly complicated because the curve can be Bezier points or points like polygon points, all sort of stuff. I guess it's easier to just do the simple one first, like in this example. So just create a cube, and with this cube you can do an array, maybe like 10 of this cube. You can adjust it as you please. So this is Sverchok Curve Modifier basic. Now if you ever want to modify this object using a curve, you can say create a circle, for example, and then just assign the circle, create a curve modifier, and assign just specify that circle or curve, and then your array objects get modified, and then you modify the curve with edit mode, and then so on and so on. I actually want to do this using Sverchok, just to do all this kind of editing using Sverchok. So let's see, for this guy over here, let's see if we just jump into Sverchok and then create a line, and then use a viewer draw and have a look. So this is line, okay? By default, it obviously create a line, and can be any length and can be any number of vertices. That's cool, but this guy is not a curve. Even if we use like a bmesh mk2, it's not gonna be a curve. But I believe we have curve viewer. There's a curve viewer and a polyline viewer. Which one you like? It's totally up to you. We can use a curve viewer, I guess. So if I plug this guy in and that guy in, we should have curve object. And with that curve objects, we can modify this guy. Let's try that. Just specify the curve from Sverchok, and then now, so you can see the curve is kind of doing something. Let's say, supposedly you want to use randomize input vertices, and we get something like that. Well, it's not what I'm expecting. It seems to be doing something weird there. Probably, let's say, try fit curve and alpha. This doesn't seem to work, which is a little bit weird. Maybe, yeah, that's a little bit weird. If I use polyline viewer, and then plug this guy in there, and this is called gamma. Select our array and then use our gamma, and this guy use a fixed count. So this actually worked better. See, apparently curve viewer doesn't work. Polyline viewer is better for this. Look, okay, so that's what I was kind of the result I was expecting. So let's use gamma. So we can randomize the seed, we can adjust the amplitude in XYZ, whatnot. Yeah, that's pretty much it, except that we can do more like fit the curve, fit to the gamma. This is better because now we can adjust the line, which will adjust the array as well. Very cool. Yeah, and then if you want to do anything to the curve, like let's use like circle for example, plug that in, and there we have something that looks like a circle. Yeah, of course you can do that. Let's go back to line. Keep it simple. Line, randomize input. Yeah, let's don't do the randomized input like that. Let's do our own like wave. Remember how you can do the wave? So we have vertices here, right? This is vertices coming out from this node, and it's 64. Let's make it like 20 points for now, and we can adjust the step. And this guy, if we check on the stethoscope, it's a bunch of numbers. 0, 0, 0, 2, 0, 0, 4. It's you can see the number that's going up is in the x-axis. Obviously, now we can actually use vector out and vector in. If I plug the x into the z, the line goes up, and whichever I'm plugging in this into will control the directions. Keep the x on the x-axis, but we can adjust the z position, for example. For the z position, we can use sine wave. You have learned this. X plug into this guy and then into the z. Now we have wave. It's the basic thing that I do many times, but still pretty interesting. I mean, it's easy enough to demo. Now here we can do a little bit more. Like if you want to make this wave kind of moving, we can use vector math. Actually, we don't need vector math. We can actually just shift the x position. Okay, just use math in here. You can do it in many different ways, but I think this will work. So the x can be offset. But not in the x. Actually, it's in here. In this thing that goes into the sine, we can offset it. Now it's like a snake moving. Cool. Let's use a frame number for it. Use frame number, and by default it's gonna be too fast. Let's use math once again, and then just use multiplier and multiply by 0.02. Now it's too slow. 0.01, 0.1. All right. We can reduce or increase the stepping, and then we can increase the vertices, whichever you want. And then of course here with the sine we can also multiply it. by a number to control the amplitude. So now that's controlling the amplitude. Currently it's looking pretty funky, like a super low res. Let's try to fix that. Increase the stepping, yeah, and increase the amplitude frequency, and increase the number of vertices as well, maybe 60, and then just the usual wave, and then control the amplitude, control the stepping. Here you go, you have like a snake. This is just an array in Blender. This array is kind of always conforming to the length of the curve, so you have this. If you want it to be spiral, it's easy, super easy. You just plug something into the y, like the cosine. So the same kind of setup here, but just use cosine. So this guy is still there, and then this goes into the multiplier, and then this goes into there. We have spiral, and we can control this. The frequency, maybe something like that. Yeah, it's a pretty simple. Let's see. So you can play around with the number, get some interesting design. This is kind of a trial and error as well for me. So this seems to be quite nice. It has enough detail and resolutions to do this. Increase the step, and reduce the step or increase the step. If you, oh yeah, you can also control the array. If this is 1 and you turn on merge and you use the wireframe modifier, you get something like this, and you can increase the cube, the original cube, and you get something like this. Of course, with a wireframe you can turn off even thickness and then increase the thickness, and you have this kind of spiral look. Yep, that's pretty simple. Relative offset to 1, merge, okay, distance doesn't affect. It's fit the curve, maybe fix the length, fit the length. You can also use this. Fit curve, I think is works best. But you gotta ensure the curve has the enough length to cover all the array. I think the thickness of this curve doesn't really matter. That's the actual curve. We can actually zero it out so it doesn't render, and just render this guy. And you can do all sort of thing here. Vector in, randomize input vertices, randomize it in the Y and the Z. In the X, Y, and Z, and you get this kind of curve. A little bit more random. It's doing bit of wiggle. The length doesn't match anymore. Wonder why. Maybe the step is too big, too small. Maybe amplitude. Okay, amplitude is too big. 10. Yeah, you just simply play around with the number. Oh, maybe the cube is too big. Select the cube, scale it down. Now we have something that looks like a telephone cable. Yeah, actually the curve here, it's totally up to here. Currently we just use the sine or cosine to give the spiral. You can use any kind of lines actually. I can't think of anything at the moment, but yeah, it depends on how good you are with the math, and then what kind of line design that you have already here. Hilbert, random vector is always, this always works kind of nicely if you like that kind of random look. Of course, I'm actually using the sine wave thing in there, so that's not a good idea. Back to that guy, and then here you can just, if you cut this line and then just replace it with a random vector, you get that kind of random line. And if you use script node and use petal sign, plug in the vertices, and you have, what do you have? You have the petal. Oops. See a flower, and you can also use the script node and Fibonacci, the usual drill, and you know, these, and not too many points. Yeah, maybe I need to scale this down. Number scale factor. That's actually the Fibonacci. Can be smoother. B-spline. Turn on B-spline and you have that look, flower. Scale it down further. Yeah, I guess it's pretty interesting, and feel free to play around with it. Maybe scale it down further. I don't know, I think the number is super sensitive. Oops. Yeah, anyway, all you need to do is just provide the points. I think for many of Sverchok, for the basic stuff, you just provide points and plug it into the vertices, and you'll get something. Because points, with any points, you can easily kind of connect the dots. Okay, so any kind of points, if you can think of points that even something that's like a grease pencil. Let's say you draw the grease pencil and then you want to turn the grease pencil into the curve that's modifying the array. You can do that easily. Okay, we already know how to resample grease pencil into curve using Sverchok. Yeah, a lot of possibilities with curve. Then on the next video, probably I will kind of hack a line. Let's say you already have a curve connected here, and the curve is already in the 3D view. You want to be able to modify the curve directly from Sverchok. Yep. Anyway, that's for next one. You can leave me comments, suggestion down below if you have any. I'll see you in the next live noding. Thank you for watching once again. I'll see you next.